chemistry practices any great game.
Okay, in our last class we discussed about the insect pheromone synthesis, more particularly uh, disperlure. So more particularly, we discussed about three methods. So one is two are common, and third one is stereoselective synthesis of disperlure. And today we will discuss about grandisol. So grandisol is a component of Bolvillei pheromone. So this is the image of Bolvillei insect. Okay, and it is belongs to the aggregating pheromone. So one of the pheromone elicited by male Bolvillei, and this will be the scientific name of this male Bolvillei insect. And here, so this on steam distillation. So steam distillation of the crude extracted of this is the number, and this will be the weight of Villi ficus. And these male Bolvillei insect, this caused the destruction of cotton plantation. And here this will be the structure of uh, uh, what you call uh, grandisol. And maybe you can look into the difference. So both are same. You can write this moiety as well as this. And here this carbon is the first carbon atom, and this carbon will be the second carbon atom. So first carbon atom is having R configuration, and second carbon atom is having S configuration. And both the structure represents grandisol. And okay, let's give an entry. Right. Okay, so this will be the IUPAC nomenclature. So 1-methyl, so that means this methyl is called 1-methyl. So to this itself, this group is there. So name of this 2-hydroxy, this is 1, this is 2, 2-hydroxy ethyl. So this is the one. And second position, this is the second position, and this group is called isopropenyl. So this group is called isopropenyl, and this moiety is called cyclobutane. So 1-methyl in a bracket 2-hydroxyethyl, that means this moiety, and this group is called uh, propenyl group. This group is called isopropenyl group, and this is a cyclobutane. So this is the IUPAC nomenclature, and the general name for this compound is grandisol. And this carbon is first carbon, this carbon is second carbon. First carbon represents R configuration, second carbon represents S configuration. So here also I am discussing two or more methods. The first method is the I'm mentioning method 1, synthesis of grandisol. And you know that this is ethene. Ethene, when it is treated with a cyclopentanone, more particularly what it will do, it will be nothing but a 2+2 cycloaddition. So 2+2 cycloaddition in presence of light. Okay, that means there will be a new bond formation between this carbon and this carbon, this carbon and this carbon. So that is how a bicyclic compound is obtained. I think you are aware about photochemical reaction as well as the pericyclic reaction. This is the photochemical cyclo addition, 2+2 cyclo addition. So what will happen? So this key, you know that this carbon is alpha carbon, and this proton is called alpha proton. So more particularly, we can also say that enolic proton. So in presence of acetone, what will happen? Uh, this proton, okay, is captured a base, and that can attack carbonyl group of the acetone. So there will be a removal of water. That means this H as well as this H is, and oxygen of the acetone is going out and forming a alpha beta unsaturated ketone. This is a ketone, and the obtained one is alpha beta unsaturated ketone. At this moment, so a base, it's not a base, a organolithium compound. So organolithium means, more particularly, it is called methyl lithium. So methyl lithium, it will attack a carbonyl carbon. So when the anion part of the attacking a carbonyl carbon, and this bond pair picks up a proton when it is acidified. So that means the obtained compound is hydroxymethyl, methyl substituted product. So let's give an entry. Okay. So methyl substituted product is obtained. So this methyl substituted product, when it is treated with ozone, I think you are aware about ozonolysis. So ozonolysis, what it will do? So there will be a reaction of double bond. So here, what is the double bond is here? So the double bond is alkene. So this is the one. This double bond react with O, O3. O3 means ozone. So initially there will be a formation of triozonide. So TRI, triozonide means O, O, O. So this bond formation, it will forming a bond with the double bond. I think this I explained in previous semester, more particularly when I am talking about ozonolysis. So triozonide is one intermediate. This triozonide rearranges to convert into a ozonide. So once there is a formation of ozonide, so there will be a transformation. How the transformation? This bond can come over here, and there will be a breakage of this bond. That means this bond coming over here. Let's give an entry. And then, okay, so this particular bond means bond pair is coming over here. This bond pair moves over here. This bond pair comes over here, and this bond pair picks up a proton. This bond pair picks up a proton. So that is how a ketone here. That means this carbon converted into ketone, and this carbon converted into carboxylic acid, and acetone will go out. So here the living group is acetone. So this is the product obtained. So a product obtained here ketone, and this will be the carboxylic acid. So what will happen now? At this moment, it was treated with halide. So what is the name of halide? Triphenyl phosphine methane is the halide. And you know that this particular reaction is called Wittig reaction. So what it will do? It will convert a ketone into uh, alkene. So in place of oxygen, this CH2 will form a bond. So that is how a alkene is obtained. So now you know that this is a carboxylic acid. So this carboxylic acid on esterification. So esterification means conversion of acid into ester. So that means in the first step, acid is converted into ester. In the second step, that ester is reduced to alcohol. So in the second step, ester is reduced to alcohol. So what is the product obtained? The product obtained is so this one position R, that means this carbon is R configuration, this carbon is S configuration, and this structure is called Grandisol. This is the first method of preparation of Grandisol. So that means, so first step is 2 plus 2 cycloaddition, second step is condensation reaction, and third step is a substitution reaction. Okay, and fourth, this is the substitution reaction. Fourth one is ozonolysis, and these two are intermediate. Okay, if you are able to write from this moiety to this, it's fine. These two are intermediate, and this reaction is called Wittig reaction, and this reaction is esterification followed by reduction. So this will be the Grandisol. So with this, let's look into the second method of synthesis of Grandisol. So here I am taking a substitute. I think you are aware about this moiety. So this moiety itself, I am taking for the second step, second method of synthesis. Okay, look here. So this is the one. So this, instead of going for ozonolysis, so in the second method, it was treated with MCPBA. I think you know that what is MCPBA. MCPBA is metachlorobenzoic acid. What it will do, it will convert a alkene into epoxide. Once the epoxide is obtained, so there will be a ring opening. So ring opening means maybe a proton source. Okay, proton source means what you will get, hydroxy here, hydroxy here. That means a diol is obtained. So ring opening with acid source means epoxides gives diol, more particularly vicinal diol. That those vicinal diol, when it is treated with peroidic acid, so peroidic acid, a diol is converted into carboxylic acid as well as ketone. So this is that means a diol means OH here, OH here. That product is obtained when this epoxide is treated with proton source forming, and that diol, when it is treated with peroidic acid, it gives ketone as well as carboxylic acid. So then what will happen? Again, it was treated with elide. So, and this particular reaction is called Wittig reaction. And name of this compound is triphenylphosphine methane. So the what it will do, it will this CH2 replaces this oxygen. Oxygen was taken by triphenylphosphine and converted into triphenylphosphine oxide. So then this is the compound is obtained. This compound on reduction, more particularly lithium aluminum hydride reduction. So lithium aluminum hydride converts a carboxylic acid, this carboxylic acid into alcohol. So what is the name of this compound? This name of this compound is called Grandisol. So in the Grandisol, this carbon is the first carbon. First carbon is having R configuration, and second carbon is having S configuration. So this is about two methods of preparation of Grandisol. Okay, so with this, I will go to the one more insect pheromone. It's called Brevicomin. Okay, this is the compound. What is the compound? Brevicomin. So Brevicomin is a pheromone. More particularly, it is isolated from Dendriotis brevicomis. So it's a scientific name of this particular insect. It belongs to a aggregation pheromone, and this picture is nothing but a western pine beetle, and what these insects do, these insects destroy the forest. How they destroy? They will make it into a frass of female, more particularly a mixture of fecal material and extracted wood particle. Uh, this insect, and from this insect the isolated compound is Brevicomin, and Brevicomin will have a structure of this will be the hexo one and this will be the endo one. So exo and endo with respect to this ethyl group. If this ethyl group is away from the observer, means away from this moiety, is exo, and if this ethyl group is towards the this moiety, then it's called endo, and this will be the general structure of this moiety. So this, you know, that chair form is written, but here it's a general one, a bicyclic compound. You can write this, but what is the need of writing exo? So exo is the active one, so that is the reason you need to write exo. So what is the IUPAC nomenclature of this? So exo means the ethyl group is away from this chair forum. Okay, uh, then you can say that exo. 7-ethyl, this position is called 7-ethyl. 5-methyl, so this position is called 5-methyl. 6,8 dioxo, so this oxygen place 6,8 dioxo, and you know that it's a bicyclic compound. Total number present in this compound is octane. So this will be the IUPAC nomenclature. Sometimes if they are asked you question in a IUPAC nomenclature, you should be able to write. You should be able to recognize that this IUPAC name is nothing but a Brevicomin. So let's look into the method 1 synthesis of Brevicomin. So you know that this is what is called as cyclohexanone. Okay, more particularly cyclohexanone. So you know that what you call trimethyl lithium. Trimethyl lithium. What it will do? Silide is in nucleophilic nature. This bond pair attacking this carbon. So it's a fourth position, 1,4 addition. Then what will happen? This bond pair is coming over here and this bond pair picks up this lithium. So that is how intermediate is obtained. And then this bond pair can come over here and this bond pair for react with electrophile. What is electrophile here? Ethyl iodide is the electrophile, and this is the product obtained. And this product, when it is treated with MCPBA, and you know that what is MCPBA, so I think more particularly you are aware about Baeyer-Williger oxidation. What is Baeyer-Williger oxidation? So insertion of oxygen. You know that this is a 6-membered ring. So this 6-membered ring is converted into 7-membered ring. A ketone is converted into lactone. So this is the lactone. What is lactone? Lactone is a cyclic ester compound, and this will be the reagent responsible for the conversion of ketone into lactone, and this particular reaction is called Baeyer-Williger oxidation. So then this moiety, when it is treated with potassium hydroxide, so what it will do, potassium hydroxide? So it will cleave. How it will cleave? So more particularly, you know that OH can attack this carbon. When OH is attacking this carbon, this bond pair picks up a proton. So that is how a product is obtained. At this moment, the bond pair, so the bond pair means carbon and silicon bond pair can come over here and OH will go out. So here what is the living group? Living group is trimethylsilyl hydroxy is the living group. So this is happening in presence of potassium hydride, it's base, and THF is a solvent, tetrahydrofuran. So what is the compound obtained? The compound obtained is a double bond, a alkene is obtained. So now this moiety is treated with what is called as organolithium. So what it will do? It will attack a carbonyl carbon, and this a hydroxy group go living group will go along with the lithium. Lithium hydroxy is the byproduct, and this will be the product. Again, this product is treated with MCPBA. So here, what it will act as a epoxidation. So this double bond is converted into epoxide, and the obtained epoxide, when it is treated with a zero point 0.1 molar hydrochlorate, means this is the chlorate, uh, uh, perchlorate more particularly, okay, perchlorate, name of this compound is perchlorate. So what will happen here, you know that what is called as this epoxide, a ring opening. So ring opening means O will attack this carbon, and this bond pair picks up by oxygen and takes the proton. So that means epoxide is converted into diol. So obtained diol undergo rearrangement. How the rearrangement? You know that the bond pair or the lone pair present on the oxygen can react with this carbon, and this bond pair react with this carbon, and OH is going out, removal of water, and forming a exo compound. Exo compound is in the ratio of 87.5% yield, okay, and endo is around 12.5% yield. So this is about how the uh, uh, what is called as brevicomin is synthesized starting from cyclohexanone. Okay, how do you synthesize brevicomin starting from cyclohexanone? Means you can write this particular method. Otherwise, give one method of synthesis of brevicomin. Also, you can write this particular synthesis. So what is happening in the first step? Treating with trimethylsilyl lithium, a substituted product is obtained. This substituted product on treatment with ethyl iodide, it's electrophile. The obtained compound is this. This compound is subjected to MCPBA, it's Baeyer-Williger oxidation. A ketone is lactone is obtained. Lactone on ring opening gives hydroxysilyl compound. This hydroxysilyl compound on treatment with base gives an alkene. This alkene, when it is treated with methyl lithium, it gives a ketone, and this ketone means a isolated alpha beta unsaturated ketone, when it is treated with MCPBA, double bond alkene is converted into epoxide. Epoxide on treatment with perchlorate ring opening reaction takes place, forming a vicinal diol. This vicinal diol undergoes dehydration, forming exo compound, more particularly 87.5% product. 87.5% product is formed, is exclusively exo, and this is the required one, and it is the biologically active one. So endo, it's formed around 12.5%. So with this, I will go to the second method of preparation of Brevicomin. So what is the name of this compound? You know that how many carbon atom? 3 carbon atoms is there. So dibromopropane. So this dibromopropane, it's treated with active methylene compound. What is the name of this active methylene compound? It's aceto acetate. Aceto acetate. More but ethyl. So here this is the ethyl acetoacetate. Ethyl acetoacetate, it's a liquid. Of course, dibromopropane is also liquid. So in presence of base, what it will do, you know that this is the active methylene carbon and this proton is called active methylene proton. This is sensitive to base and there will be a anion formation. That anion attack this carbon and Br is going out. So that is how a compound is obtained. So this particular compound means it's a substituted product uh, on just heating. So on heating, further heating, what will happen? Decarboxylation. This carbon dioxide is going out. How it is going? The this anion can come over here. Uh, so what I mean to say that this ester is there, no? So ester on treating with sodium hydroxide, ester is hydrolyzed to acid. That acid on heating undergoes decarboxylation. That means anion can come over here and this anion can come over here and this bond pair can pick up a proton. So that means removal of carbon dioxide. So what it means when dibromopropane and ethyl acetoacetate on treatment with sodium hydroxide, it gives a substitution as well as decarboxylation and also hydrolysis. So giving rise to isolated, giving rise to enol. This is ER. So this enol undergoes keto-enol tautomerism. That means the bond between the oxygen and hydrogen, that bond pair is moving over here and this can pick up a proton forming a ketone. So this ketone, when it is treated with a ethylene glycol. What is ethylene glycol? CH2OH. CH2OH is called ethylene glycol. So a ketone, when it is treated with ethylene glycol in presence of H plus, so what it will do? A ketone is protected. CO is protected. So this step is the CO protection and this is the ketone and the name of this compound is called ketol, okay, because ketone is protected at this moment. So this was treated with triphenyl phosphine. So what it will do, it will convert a bromo into triphenyl phosphonium bromide. So triphenyl phosphonium bromide, that means what you are doing, you are just by treating with the triphenyl phosphine, a bromide is converted into halide. That halide is treated with aldehyde. So what it means, a halide replaces this oxygen forming a compound like this. So that means you can observe that CH, this aldehyde CH2 is this aldehyde CH2 is this, and this CH is this. Okay, so that is how this is nothing but a Wittig reaction. So on Wittig reaction, this bromo compound on treatment with triphenyl phosphine and followed by halide, it gives a compound like this. So this compound on treatment with what is called as MCPBA. What is MCPBA? Metachloroperbenzoic acid. So what it will do? It will convert this double bond to epoxide, and this epoxide on treatment with on treating with dilute sulfuric acid. So what it will do, you know that dilute sulfuric acid means it will act as a source of proton, and then what it will do, so there will be a, ring closure. How it is closure? There will be a new bond formation between this oxygen and then this carbon. So that is how, and removal of water forming a exo compound. So maybe what you can do, you can also try to write the mechanism for the conversion of this moiety into this compound. And here the product obtained is of 75%. 75% of product is more particularly exo is obtained. And then with this I will go to the next method. The next method is called stereoselective synthesis of Brevicomin. Stereoselective synthesis of Brevicomin. uh, I will move. Okay. So you know that what is the name of this compound? So this compound name is cyclohexadione. Cyclohexadione. So you know that this carbon, it will act as a methylene carbon, and this proton is it will act as a active proton. So in presence of base, uh, it is possible to get an anion here. That anion attack electrophile called ethyl iodide, forming a substituted product. Once there is a condensation, uh, uh, it's a condensation reaction because removal of water, and a condensed product is obtained. So you know that in the first step, so keto-enol tautomerism, that means this bond pair can come over here and this bond pair can fix up a proton. So that means it will form a enol. Enol means double bond here, OH here. That enol, that alcohol, when it is treated with phosphorus trichloride, what is the role of phosphorus trichloride? Phosphorus trichloride, it will act as a chlorinating agent and it will convert hydroxy compound into chloro. So that is how a chloro is obtained. At this moment, so when it is treated with the organolithium compound called methyl lithium, so what it will do? It will attack a carbonyl carbon. So when there is a new bond formation between this carbon and this carbon, this bond pair is going up and it won't sit there. Again, the bond pair is coming back. When the bond pair is coming back, this bond pair, the bond between the carbonyl carbon and ethyl and sp2 carbon atom breaks. Breaks in the sense the bond pair is coming over here. When the bond pair is coming over here, Cl group is goes out. So that is how a compound, more particularly triple bond and keto containing compound, is obtained. This triple bond keto containing compound is subjected to Lindblad catalyst. So what is the Lindblad catalyst? Hydrogenation in presence of palladium barium sulfate. Uh, so what it will do? Lindblad catalyst is useful for the conversion of a triple bond into a double bond. So Lindblad catalyst is a useful catalyst. It only selectively reduces triple bond into double bond. Further is not possible because further a catalyst spoiler is used in the reaction. So catalyst poisoning material like quinoline is used. Quinoline is a quinoline or sulfur is used that will destroy the catalyst. Therefore, it will stop at the reduction at the double bond stage. And then, so after the Lindblad, so this particular reaction is Lindblad catalyst. Lindblad reaction. So triple bond is converted into double bond. Then it was treated with MCPBA. What is the role of MCPBA? MCPBA converts a double bond into epoxide, and this epoxide is converted into Brevicomin. How? By the rearrangement called Wessiman rearrangement, Wessiman thermal rearrangement. You try to write the mechanism for this to this. Otherwise, you can also look into the what is Wessiman rearrangement and what is the mechanism for the conversion of a epoxide ketone into a, what is called as Brevicomin. So this is about stereoselective synthesis of Brevicomin. So today we discussed about Grandisol and Brevicomin. So more particularly synthesis and stereoselective synthesis uh, about these two insect pheromones. Maybe in the next class, let us discuss two more insect pheromones. There are seven insect pheromones. Up to this, three is completed. So that means tomorrow, let's discuss two more insect pheromones, and the next day, Wednesday also, two more insect pheromones. So that means maybe by the end of Wednesday, I will be able to complete this insect pheromones. Maybe Thursday I will start prostaglandins. This is about tentative plan. So with this, I will stop at this stage. If you have any doubts, you can ask me. If there are no doubts, you can log out. And at the same time,